I was part of a sounding rocket payload workshop at Wallops Flight Facility, where I was required to navigate various schematics and circuit diagrams, like this Geiger counter, solder and glue components, conformal coat and assemble a large sensor array including humidity and temperature sensors, accelerometers, and an aforementioned Geiger counter, all to be launched in a 15-minute, 114-kilometer peak suborbital atmospheric data recovery mission.
So what we have here is a simple beam brake circuit. It's in three main parts. We have an Arduino that is housing our power supplies, as well as some logic pins that we're going to be taking advantage of. Below, on the breadboard, on the right side, is an op-amp circuit that's going to be doing our comparison of a light level or intensity on a certain photoresistor. And the right side is a 555 timer that is controlling a small speaker. Now, basically, when light is incident on the photoresistor, it's going to maintain a low voltage below a certain threshold that will output a low signal on the op-amp, which is connected to our input pin on the Arduino. And when the beam is broken, the voltage will go high above the threshold and will output a high signal into our input pin. Now there's some minimal coding that is being done here that is just reading the voltage level on this input pin and is deciding whether or not to output a high or low signal that powers the 555 timer. I can give you a small demonstration. Now right now you see the red hue. I'm pointing a laser light inside of this little paper cone that houses the photoresistor, and it maintains that low resistance on the forward resistor of a voltage divider, which maintains a below threshold signal into the op-amp, and like I said, a low output, which does not turn on the 555 timer. As soon as the beam is broken, we get an alarm signal. So that's our alarm signal. It's about, I don't know, an 8 Hertz output on the 555 timer to the speaker. And that's about it. Now, the op-amp is in a Schmitt trigger configuration. There's no completely necessary reason that I made a Schmitt trigger instead of a simple comparator, other than I wanted to do the math and make a more robust circuit, which is the nature of a Schmitt trigger. And that is my beam brake circuit.